Good Thursday to you all. Gonna finish up content on Fusion 360 Sculpt today. A couple of things we're gonna cover. One that I like to do at the beginning of the project is to make a simple coffee cup, but forgot about it, so I'll cover that one quickly. I'll touch on pipe and how fun it can be. Lofting, which lofting and sweep, very similar in nature, in my opinion. And then some of the powerful things you can do with Symmetry. Finally, we will throw it over into a little bit of simulation just to see what this curvilicious form is going to do, and we'll throw it under a stress test. So that's class. Let's start. All right, super basic coffee cup, coffee mug. Think which one I want to start with. Here we go. We'll start with our rounded box. I haven't done that yet. So my 70s cool. Once again, not really going for size. What I want to do, instead of a 2x2, I want a 3x3. Or is it a 1x1? There we go. There we go. You see how we went from being square to being rounded? Pretty important. And then height faces, I don't know, 6. I can get rid of them if I don't want them. Overall scale, give me everybody. Double click. That's a move, sorry. Give me some sizing. There we go. Most of our work's going to be done at the top anyways. We're going to subdivide in a second to get that handle. But we've got to take this guy and put it on the inside. I'm going to do one insert edge around the top. Don't like you? Okay, cancel. Repeat. All right, good. Just a little bit extra geometry to work with. We're going to scale down this one surface. Whoop. And then we can slip it inside by doing that, right? So you want to pay attention to this, right? If it gets too sharp, like I'm not sure if it would like self-intersect. In theory, I don't think it could, but it's not really good for it. So I might throw another one of those insert edges. All right, the further you pull, the more pointed it gets. All right, so what do you need to do to avoid that? Right, we got to extrude again. So that one, I don't want to edit form. I want to shortcuts. No, fine. Extrude. All right, now we got to start growing that guy back out. Modify you. Bit bigger. Let's pull you back. You're getting kind of crazy. All right. That's good, but now that guy's too thin. A little modification. I could do the whole selection, which is super nice, but when you only got 4, I'll live with 4. About bigger, right? See how this guy's getting too thin on me? So I need to throw another line, and then we'll do I want to cut it in the middle. Looking. Section analysis. All right, we'll get there in just a moment. Give me a bit more geometry up at the top. Okay. Now we can manipulate these. You two. Scale you in some. There we go. See how we're getting softer? There we go. So now we have our internal volume. Let's use or leverage the section analysis right here. Right? Check my wall thicknesses. It looks goofy. I see that. Okay. So it's not letting me see everything. Will it allow me to get all right, don't know this song by now. All right, if I can't get the control that I want, once again, I'm going to go with the whole insert edge business. The one thing I'm hoping is that it's not distorting my analysis. All right, we look to be okay. I can do without it. Video check. Great. All right. Pretty much done with this internal volume. Now I'm pretty confident. Yep, that's what I thought. If it was hiding, you couldn't select it. So what about the handle, Ben Bush? What about the handle? We'll make a mug. I want this guy to connect. Like I said earlier, I think a subdivide is going to be a bit more wise in this situation. Subdivide U. Got a little distortion. I can change it up later. Not a big fan, you know. So that gives me two options. One, I can just try the whole extruding on these pieces and scaling those in. That's option one, right? It does create that internal structure, or it gives me kind of an offset. I just think it's going to look ugly. All right, so we're not going to go that route. We're going to take a little bit longer and insert edges. Bottom to top. I really like just 0.3 over would be satisfactory, right? That'll divide me into thirds. I'm okay with that, and I'll do the same thing one more time. .3 actually, ooh, tricky. Negative 0.3, good. We are getting some weird shapes out of this. Try it again, but instead of selecting like so far up top and below, I do need that one. I think selecting that bottom edge is being detrimental. Yep, same issue. I'm just going to go the straight up subdivide and adjust kind of my starting point. Repeat here, and I'm going to take that part to that part. Bridging 1, 2. I can't bridge yet, right? Because this is going to like muddy all that up. What I need to do is kind of bring this out from the form. Here I am doing things the hard way, right? I could go back and do the insert edge. What I'm trying to do is get to like this area the entire time, but sometimes I got to go through it. Weird. I can show you how to deal with that in a second, but what I really wanted to get to was extruding these. Yep. All right, that way it's coming from like the middle of the mug. All right, before we get too far out, let's change the form of them. Give me modify. I don't want an edge. I just want a surface. All right, scale in. Better. I could do the same thing for the back. I'm gonna extrude one more time. Okay, now this is where it's a bit of a fun part, is I need to rotate these surfaces down. Right, so we'll rotate 45. Let me go a bit more than that, 65. Rotate y'all up. Right, and I'm going to extrude y'all towards one another. Is fine, and then I can keep on using this modify. Faces, thank you. At this point, I can rotate it to being pretty much close to vertical. There we go. Repeat this up here. 2, 3, 4. Wouldn't mind pulling that down just a notch. Okay. And from this point, I'm good with using the bridge to connect these together. I've got to get all 4 ports on top, all 4 parts on bottom. Starting point is the same, direction's the same. Nice. Got a pretty little handle. Now, we'll look at this. I don't think I need to address this, but this guy, actually that might be the internal structure doing that. Let's change it in this box mode. Don't need to change it, just need to modify it. Scale it. I don't mind scaling all the directions. There we go. And so now I'm going to finish form. I want to go back to the Sculpty mode. Alright, so inside's fine. It's just there's some disagreement happening with this surface. That's not showing up when we have the box mode, right? Just gonna look at it, delete. Yeah, everybody looks pretty good. Interesting little issue. My guess on how to fix it is like we gotta take something away. I want that to be rounded. It's the first time I ever got this little bit of an issue. Let me look at points. I don't want to spend much more time on that because we're not learning anything else from this. We've kind of already picked up all the lessons, how to put something inside and how to run bridge. But alright, gonna leave you here, even though, man, that is an ugly coffee mug. But that's the point, and then that's the point. Okay, so no more coffee mug. We're gonna jump into pipe, which has lots of different applications. So if you've, make a curve to do a pipe operation or do a swept one with a circle, then you know what a pipe is. But let me show you a little more fun you can have now that it's a T-splines, sorry, not T-splines, a Sculpt Pipe. I'm going to start in just normal sketching. I want more control over my line. So basic sketch, I'm going to make us like an ugly spiral. And one more. Okay. And what I would really appreciate doing is being able to move these points. Downside is I'm pretty sure because they're dark, they're constrained. Let me try one more approach. Do you have control? All right, cool. Perhaps there's a better way to make spirals in Fusion, but since I don't use it on the daily, this is how we're getting to that outcome. Alright. Ooh, too much. Chill, chill. Alright. We got us a spiral happening. Alright, so this is your basic three-dimensional curve. Now that we jump into our sculpt function, I can assign in a pipe. Right, it's gonna ding, 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 ding. Look at those fun sections. A couple of things, right? So your pipe diameter here, you can get it previewed box mode or smooth mode. Just for the sake of the next thing I'm going to do, I want the ends to look pretty. So instead of them being open, I'm gonna make them square. You can also make them pointy. Have no reason for that. Square is cool with me. And then segments. I want as few as segments as possible, but I don't want it to really deviate from my initial intent. Alright, we'll say that guy's good. So, fun part is, yes, it is a smooth, curvy, sectiony form, aka T-spline surface, but you can start bridging some things together, which is like kind of a new fluctuation you can put on these things. Same starting point, same direction. Okay. Ooh, we broke. Maybe it wasn't the same starting point, same direction. Not you. Yeah. Okay, so you need to get to there and go the same direction. Okay. Yeah? We think so? Nice. Okay. Let's do one over here. Trying to find good ones that would match. Let's do these. Repeat. Bottom to inside, same starting point. Nope. You need to be here, my friend. And can we change your directions? Not sure, but we'll see. All right, that works out good. So we're kind of building like this vertical reinforced structure. We've got a lot of mass here. If I want to move some of the mass, I tried it earlier. If you just go straight up for the bridge here, there's not enough math, and so you'll get this breaking or really thin structure on the edge. To me, that's pretty much useless. That might not be self-intersecting. Nah. So to avoid that, subdivision, top, repeat. Wrong side. Come here. Subdivide on the bottom. Okay. And we'll just do a small section of it. I want to go straight through the middle, but you know, you have to have thirds to actually have a center. I know I could get through like, I don't want to go that direction. We'll see if this works. Bridge us. Yes. Left side. Same starting point, same direction. Yes. Broken. I guess I was wrong with that. You. Same parting point, same direction. Now that guy's good. Kind of the same, boat I was earlier. What I want, I don't want quarters. I want, a third. You want a Nana? All right, let me get this kid a Nana. All right, banana has been delivered. So fast, so fast. I'm gonna do another kind of round of subdivides again. Right, that gives me, it's not the inner third, but man, it's a lot faster. Back up, back up. Best. 1, 2, 3, 4. Yes, of course. All right, now I got some inner section that I can do this bridge with. 1, 2, 3, 4. 1, 2, 3, 4. Same starting point, same direction. No. Yes. All right, so this is what I was going after. I wanted there to be enough mass on the outside. Right, I could do the same thing to the entire thing and start connecting these tinier structures. Or you could have more subdivisions when you start out. So don't think like this is a pipe where you can make connections with other pipes, and this is like the part that I love, like this really gooey intersection change, because like that's inherently really strong. Whenever you have like a really a sharp connection or a crease, that's the weak spot. But this happens to morph in a way that has continuity. I like it a lot. And when I'm playing on Sculpt or T-splines, I find myself really gravitating because it allows me to do this continuity, this curve networking really fast, really easy. Okay. Pipe, great fun. Finish the form. I'm going to hide you. You're not consequential. Let's look into lofting. In order to do lofting, I need some right object to loft. It doesn't really matter. I'll make my surface here. Let me get back to what feels normal. All right, you. Now, big thing, because Fusion, Sculpt, or T-splines is like smooth, if I choose geometry with angles or corners, it's just like adding a crease. So since I don't want to add creases, I want to leverage its smoothness, I need to pick elements that are already smooth. I hope that makes sense. All right, basic circle, good. Now we need some like offset planes. I don't want to go straight. I'm going to do an angled first. All right, you, rotate you, fun degree, offset you. Whoop. Now we'll sketch on this guy. And once again, want something smoothie. Slots are great fun. Okay. Finish that sketch. And last one, I want the original, another offset, well, another angle. Could do things easily. Not as fun. All right, we'll offset that. Whoop. We'll sketch on this face. Now, what I really needed to do is like, how do you go normal to in Fusion? I will give you 5 Shroot bucks if you can send me a message and tell me how do you get normal to a face within Fusion. Okay. Right, I want something curvy, something amoebic. All right. I'm only hoping that I, created enough space between these things. Finish the sketch. Now I can jump inside the form. Sketches are good. I don't really care about the body so much. Right, we're gonna loft these together. Element 1, 2, 3. Just reading through my errors. I think I might have pushed that one too hard. It's trying to correct our. Get rid of these. Try again before I make any big decisions. Loft. There we go. We have angered the Fusion powers that be. All right. Going to chill out one morning. It's not visible because my bodies aren't visible. All right. That's okay. What have I done? Okay. Let's imagine that my previous explorations were there, right? We've got a seam, right? That's going to act as a crease, but we had pretty good control over my shape. I believe it gives you 2 options. Let me get back into. I'm still in the sculpt function. What I'd love to do is get back into that operation and show you a variation. We'll just hit the undo key until 1, 2, 3. Body's on, and if you've got to like be exact on that line, it's going to require more data. Your uniform relaxes a little bit. It's not exactly on these edges, but it's pretty close. Right? Part of that is, I've used this example before. If you're trying to go from a circle to a square, a circle has all these like small, think of it as a really high edge polygon, like a 99 edge polygon, which looks circular. If you're trying to go from that to a square, which has like 4 corners, it has to do a lot of work, or it just has to figure out how to merge a lot of points. So you need a lot of data to do that. So because I'm not driving with a bunch of data, right? The more lines I add in here, the more accurate it'll be, but also more complicated. So, vary and make your decision according to what you need to. But just like any other T-spawn surface, right, I can, extrude a host of surfaces, point that direction, or probably Ben's favorite, button. We can bridge things, same starting point, same direction, right? Pretty fun. Gotta watch out for that self-intersecting surface. But there you go. There's your loft function. All right, now we get to the part that I'm self-intersecting. Told you, called that one out. I'm just gonna get rid of you. We're teaching. It's all right, I'll throw it away. Symmetry. And symmetry, not on an internal object, but with external objects, let it do a lot of work for you. So we'll go into the sculpt function. I'm going to pick me a good old quad ball. I'm not going to put it on the center. I want to put it out in this region. 40. Contemplation. All right, we'll leave you at 40. We'll give you some space. Now, this is one of the big things, right? You saw with like one span, it is a cube that has been rounded over. I don't think there's enough geometry here to really work with. 2 is your base, which I like it a lot. But 3 allows me to have like a center point without really breaking that edge. So we're going to start with 3s. You could play around with this number. No symmetry yet. So it's kind of sitting out here. I know that my origin's hanging out. Purposefully, I spaced it out. That way when I run this external symmetry, circular duplicate, this is my object. That's kind of my center point. Do I want 3? No, just not today. I think 5 would be incredible, but I've already kind of thought this idea out, so let's run with it. So I've got 4 of them. Right, so these guys are symmetrical to one another. They're still reading, so if I go, decisiones. Y'all know me. I do like the bridging. Bridging from top to bottom on one, same starting point, same direction, It happens to all 4. So now you can see, oh, well, how could you start integrating these elements? All right, let's connect them up. So we're going to bridge again. And for me, like, this is just like all straight play. What crazy shapes can I make? Same starting point, same direction. Now, important thing on this, right? I'm going to do it the wrong way and then show you the right way. If I do 3, you see how I don't have like a contour line on the mid? Now, I can still work with this, but for me, it's easier. Just like I wanted a center section, so I had to have subdivisions. I had to go in here and make subdivisions. Instead, I'm going to back up 1. I'm going to make sure when I do this bridge that I have 4 faces. Same, yeah, good, go. So that's pretty fun, right? Brand new shape. Love this transition. Bin bush, what else can we do? Well, let's use symmetry again. We're going to mirror duplicate. It just needs, it's going to want a plane to bounce off of. So I was thinking, do I want to move, copy, and then build the relationship? Or, sorry about that. I'm going to do an offset plane right there. Cool. Duplicate U, mirror plane there. All right, so how can we have some fun and connect some of these things together? Looking around. All right, let's go from corner to corner. Once again, we're gonna bridge, and if at any point it fights me, I can take symmetry off, and it will fight me at some point. All right, we broke. So this could be a good time to take it off. It could have been how many sections. I'm gonna go through one more time and just check my sections. One, two, 3. I don't want 4 faces. All right, I'm good with that. All right, pretty strong structure. Looks kind of like it came from like a periodic table. I know that doesn't make any sense. Sometimes I talk and I don't know where I'm going. What I'd really like is that loop. Right, this is going to happen to all 4 sides, which is nice. inconvenient. I'm just selecting things I don't want. Drag it all to the inside. Alright. I feel like I weakened it too much. All good. Really bleed that vertex. There's my little magic point. Go for the top. I'm trying to keep this thing. Okay. I brought some strength back to it. I'm going to pull it even further. How are we looking? All right. I'm good with that. Stretching it a bit thin, but I'm good with that. And then, let's do another connection through here. At this point, because I'm going to be working on this line, you also have the same thing with the hair dryer. I'm going to turn my symmetry off and just kind of deal with it as it is. So clear symmetry for everybody. And we're going to do one more round of subdivisions. Before I do that, let's do the smart thing. I'm going to subdivide a lot of y'all. Right, I'm trying to go for the center mass, and right now there's a line on it. Subdivision on everybody. All right, cool. Can I help you with your necklace? Okay. Come here. It's so pretty.
Is my pink wet?
All right, is that better?
Yeah.
All right. All right. Y'all know me. It's bridge time. 1, 2, 3, 4. Come over here. 1, 2, 3, 4. Same starting point, same direction. Up here, so. All right. Bin Bush is made happy. Go for it. I'm so used to the old space bar from Rhino that I do it more instinctively than anything else. Right, you're gonna learn one CAD program and that'll be like the thing you use, and the other ones, it's kind of like riding a bike. You can remember, it just takes a while to get used to it. And last one. And I have a reason for this, just bear with me, please. Yep. Okay. Very nice. I really dig the aesthetic. Minimal, webby, organic, something like that. All right. So let's say we finish this one. I'm going to take you into two things I haven't really discussed yet. What I love about this is the sculpt function, which is kind of its own section, can easily be integrated into your basic fusion stuff. So I'm going to do a sketch, top surface, go for it, line me up, basic rectangle, and if you wanted to modify this with any of your solid tools, it's like totally good for it, right? Kind of old school section view, but like this is what we're working with. So combining both the things that are like really rigorous engineer mathematical with things that are kind of fluid, formy, and artsy. I dig that intersection. And now I'm wondering, like, how strong really is this intersection? So we haven't touched on this yet, but ain't no time like the present. So we're going to jump down into simulation. Just a basic, static stress test. I need to set up at least two things to make this work. One, what's fixed, and two, where's the load coming from? So constraints, structural constraints, what things will not move. We're going to tell it like these bottom 4 points on each one, each quad. All right, 16 points, not going anywhere. That's where the load's going to be transverse through. All right, and and then what's sitting on it? Like, where's the weight being transferred to? I might run 2 of these. I'm kind of curious. And I want these to be like just straight up vertical loads, as if this was like a coffee table. There we go. I don't know how these guys got all wonky, but they need to be corrected. I mean, there could be a time and place for that. All right, it looks pretty vertical to me on those 16 points. So we have a fixed and we have a force. Last thing is how much magnitude, how much, before you put in this thing. We're going to do 5 newtons. I don't know how much 5 newtons is, but I know it'll give me a result. You know, they're not perfectly straight, but we'll say that's good. Now, let's go solve this. Solve study. This is stress test. And this is we'll call it an array. It's not really an array, but that works for me. All right. Let's be a little patient. Just going to upload to the cloud. Solve what this might look like. Kind of give me some stresses, some safeties. Now, because I don't really exist in the stress testing world, this is great information to have, especially if you're trying to have an efficient yet attractive design. You can reinforce it with information. If I was more in practice instead of theory, this is where I would be at. So, yeah, how are you? We're just watching this thing kind of. There we go. I love this preview, right? This is where the stress was applied. That's where it was, and this is where it is now. So, safety factor, it's a pretty safe shape. Now, stress, go to these parts, right? Told you I was a little bit sharp. All right, a little bit here, but overall, this is where the fail would happen. Displacement, what moved the most? That one did. What other thing? Reaction forces. I'm not smart enough to know what reaction force is. Strains, there we go. So if I need to reinforce this and make this a stronger shape, I have to compromise something that I think is very aesthetic and make that part stronger. But there you go. Now you know the hypothetical. I wouldn't say hypothetical. Now you have math-based reactions to your objects, right? So most stress, least stressed. Just cool stuff to play around with. Thank you, Fusion, for just having toys that make my day fun. All right. It's been fun. Go off and have an adventure inside of CAD.